We'll proceed on why calculus, how calculus. Why calculus, how calculus. We have come so far in the sense that we started why calculus, that started with discussion. Why calculus in the sense that discussion started with that where from this nonsense calculus came into the picture when we were happy with addition and multiplication. So calculus came into the picture not to make nonsense. Calculus came into the picture to help you. If something goes critical, if something goes complex, then we need tool for it. I mean, this is something, okay, I can lift it, but if I need to take it out, then probably through hand it may not be possible. But if I use some tool and then easily. So if things become complex, if things become difficult, then we need tool, separate tool to work it out. Anyway, there are many mathematics that we have seen. Numerical mathematics, numerical that is the most basic mathematics, advanced in sense algebra, algebraic mathematics, and then calculus, vector, and then we saw different coordinate system. Which mathematics is the most pioneer and most important? If I talk about importance, then which mathematics is most important? Certainly algebraic, certainly vector, which because it has direction and magnitude, certainly calculus, different way of calculating, certainly different coordinate system, certainly not. The most important mathematics is numerical mathematics. That is 99.9%. In 0.1%, this algebraic and calculus and vector and different coordinate system comes into the picture. But still, if I'll bring it back, so what is important? If I want to take it out, then from hand it's not possible. But if I use any utensil, any tool, then certainly I can unplug it. What is important? This tool is important or my body power is important? Certainly, body power is important. If you give tool in hand of a bird, what it will do? It cannot do it. So, numerical science is the most important mathematics on top of which everything is sitting. So, if you don't know, 17 into 5 is 85. 17 into 5 is 85. 18 into 5 is 90. Then what you will do 18x and 17x? Doesn't make any sense. Dx dfx by dx. So numerical science is the most important science anyway. But what we have talked till now in primitive calculus. If you see the primitive calculus, why calculus? We talked that three way of collection. One is addition, and next is multiplication, and third is through calculating the area. When it comes calculating the net collection through area, then algebra and integral calculus comes into the picture. More or less, if you talk in very raw way, just calculate the area, you get the collection. If you have rate of collection, just calculate rate of collection, draw a graph against the independent variable from one limit to another limit. This is what the net collection is. Like I say, if I am collecting 3 oranges per day I am getting 3 oranges. How many I collected between 5th day and 7th day? From 5 to 7. So that is like 2 days. I believe that will be excluding 7. So 5th and 6th day, 5 to 7. So if that is the case, then lower limit and higher limit and net collection. So rate of collection is there. Then rate of collection you multiply by the independent variable, and you are calculating the area. If there is independent variable day and there is 2 oranges per day, that is the graph. If you need to draw a graph, you need to have algebra. So algebra, there is independent component called day, and dependent component is function over day. The function over day is oranges. This is how the definition of the algebra is. Function over day is oranges. If function over day is oranges, then orange is, if day is x-axis, then fx is the orange collection. So this is a straight line parallel to x-axis, and that is height is 2. 2 oranges per day. If 2 oranges per day, then what is the net collection from 5th to 7th day? 5th day, one line, 7th day, one line. What is underneath? It is a rectangle. Calculate that area. What is there? 2 into 2, height is 2 oranges, and here also 2. 2 into 2, 4 oranges collected. So this area is called integral calculus. Calculating something through calculating the area is integral calculus. In integral calculus, what we see now, the equation is 2 oranges per day. 2, it's not 2. 2 into x to the power 0. It is actually 2 into x to the power 0. If it is 2 into x to the power 0, 2 into x to the power 0, then integration is, means the area is 2 into x to the power 1, 2x. So if x is 2 days, then 2 into 2. If x is 5 days, then 2 into 5. If it is not like that, it is 2x, lower limit, higher limit. So integral calculus is nothing but calculating the net collection through calculating the area. If that is the case, people saw it. If it is a rectangle, then if it is x0, then it becomes x. If it is triangle, if it is x to the power 1, it becomes x square. This proves that x to the power n is nothing but x to the power, triangle is x, then it becomes x square by 2. Then if it is x to the power n, then it becomes, area becomes x to the power n by x to the power n plus 1 by n plus 1. Powerful. Now people understood that if we need to calculate the net addition, then I have to go by area. If I go by area, then algebraic equation comes into the picture. If algebraic equation comes into the picture, then we have to find for each algebraic equation what is the area. I mean, what is the integral calculus? That is the area. If it is x to the power n, then area is along independent component x. The area is x to the power n plus 1 divided by n plus 1. We got it. So polynomial, we got it. So this is the way any technology rises. Okay, like algebra is based upon the numerical science. If you don't know numerical science very well, okay, so like it is called, I don't know what it is called in English, so it's called pahada, like 1 1 2 3 4. Like if you ask someone for a kind of 19, then 19 1 ja 19, 19 2 ja 38, 57, and like that. So these are kind of terminology in numerical science. So you should know from 1 to 30. That is very much required. If you don't know from 1 to 30, you have not memorized it, then certainly you cannot proceed in mathematics. Calculator and computer will not help you. So this way. So now if you are very strong in numerical science, then you can proceed on algebra. Then if you are very strong in algebra, then you can proceed on vector and calculus. If you are thorough, then you can proceed on the different coordinate system: Cartesian, polar, cylindrical, spherical. So like this. So step by step. Now if I know the integral of polynomial, then I can now start trigonometrical, sinusoid. So now concept is, this is the one thing that will proceed. Now second thing is that if I have fx, if I have algebraic function fx, if I do integration, then it results in another algebraic function gx, fx to gx. If I do integration from fx to gx, I don't know. I have sin x, or I have cos x. What is integration of cos x? I don't know. What is integration of cos x? I don't know. Okay, I can do it. I mean there is x-axis, and in x-axis I can draw graph of cos x. Cos x from when x is 0 radian, then it is 1. Then when it is pi by 2, it comes to 0. Then it will go negative. Then it will come back to 0 again. Okay, at 3 pi by 2. Again it will be 1 at 2 pi. So this is there. Now if I want integration of cos x, then I have to calculate the area, okay, raw area. Then I can place the limit. Raw area in the sense that I calculate the area, it would result in another algebraic equation, and then I can place the limit. I don't know. Neither it is a rectangle nor a triangle or anything. It looks like some snake kind of thing, right? For snake kind of thing, how I can find the area? Not possible. So what is integration of cos x? I don't know. What is integration of cos x? If that is the case, then if you have if you had calculated integration of cos x, that is fx to gx, then gx would have been the result. Can you find a gx for which the differentiation is fx? If that is the case, then integration of fx is gx. Now for gx, I am trying in the world. Now I came across something similar graph, that is called sin x. So what is differentiation of sin? I know what is differentiation of sin x. Differentiation of sin x is nothing but cos x. Then integration of cos x is sin x. So there is a new terminology came into picture, that is called differentiation. Like if I have multiplication, then reverse of multiplication is division. Similar way, if I have area calculation, that is height into width, that is the area where height is fx and width is x. If I do fx into x, it result into gx, that is integration, then gx by x would result into fx. So this step is called differentiation. Then this step is called anti-differentiation, that is the integration. Derivative, antiderivative. So if I have any function gx for which derivative is fx, quickly I can say the integration of fx is gx. This is the way also people started proceeding in the terms of how many algebraic equation you know the integration. For any algebraic equation, if you do differentiation, it results in what you want the integration for, then you got the integration. So that is the concept. How to find integration? Calculate the area. Or if you know fx, you need to get the integration. If you don't know area also, downwards you go. Downwards is a polynomial function, then break into polynomial function and try to get the integration. That also is okay. Or if you get the derivative, then antiderivative is the integral. How to calculate derivative? Derivative is nothing but division. If integration is multiplication of height into width, fx into x, or fx dx in calculus term, then if gx is the integration, then gx by x or dgx by dx is the fx back, that is the derivative. dgx by x or dx by x, since it is algebra, based upon x it varies, so it is not guaranteed that gx by x would be constant at every point of x that is required. Consider gx as kx, gx as kx. If I divide by x, then it becomes a constant. If it becomes constant, this proves that for any interval, division is nothing but dividing by an interval. If you divide by interval, means per unit change, that is division. Means per unit change in the denominator brings how many unit of change in numerator, that is division. That is division. Okay. If I say that 10 divided by 2 is 5, means per unit change in denominator will make 2 unit change, 5 unit change in numerator. 10 by 2 equal to 5. Per unit change in denominator brings 5 unit change in numerator. 2 unit change divided by 2 brings 10 unit change in numerator. That's why it is 10. 10 by 2 is equivalent to 5 by 1. 1. 1 unit change in denominator brings 5 unit change in numerator. That's why result is 1. So what is division? Division is nothing but to resolve something so that denominator will come as 1. That is, now there is 1 unit change, that many unit will change in the numerator. So that is division. If that is division, then division, if consider the, if kx is the gx, then kx by x comes constant, division will work. So integration of, I mean, if k is fx, the integration is kx. If kx is the gx, the differentiation is k back. Works. What about kx square? If gx is kx square, if I divide by x, it becomes kx. So division is again a function over x. This proves that division is not simple division. Division is not simple division. Division is itself is a algebraic function. So here we need some mathematics. So what is division? Division is per unit change in denominator brings how many unit of change in numerator. So if numerator is gx, that at any point x we see that division varies, because division itself is a algebraic equation. This proves that every moment the rate of change is varying. At that moment, we can say division is gx by x is better. It is gx plus delta x from x. Delta x, if I take whatever is the vertical coming, and at x, whatever is the vertical coming, which I believe many times we have discussed it. So gx plus delta x minus gx divided by delta x is the actual derivative, not gx by x. So rather than calling gx by x, which would look similar to some simple algebraic, so we call it dgx by dx. This is now calculus algebra. Calculus algebra means if I say gx by x, then it is x. If gx is x square or kx square, by x means kx. That is what? That is not true. If kx square is rate of is net collection, kx square is net collection, fx is kx by kx 2kx, fx is 2kx. If I do integration, then it becomes 2kx square by 2, that is kx square. From kx square, how I can get back 2kx? If I kx square divide by x to get the division, then it becomes kx. That is not true, because kx itself is algebraic equation, so it varies point to point. I cannot go with simple division. Numerical division would not work. So I have to go like gx plus z at any, if it is x-axis, at any moment x, because every moment of x, gx by x is varying. So at any moment x, what is gx? X plus delta x, what is gx? So gx plus delta x minus gx divided by delta x. So that is the actual division. It is also called differentiation. And to differentiate from the normal division, we now place dgx by dx, so that someone should not divide directly. Okay, that is the concept. So now what is kind of, now the question is arising that we know for polynomial, what is differentiation of x square? What is differentiation of x square? Why you are hitting your head? We know that integration of x is x square by 2. Similarly, you apply. If you know one path, other path is known. So if it is x to the power n, integration is x to the power n plus 1 divided by n plus 1, then differentiation of x to the power n is n x to the power n minus 1. So if integration of x is x square by 2, then differentiation of x square is nothing but 2x. Okay. Now we are in discussion for the sinusoid. Can we find integration of? Can we find the differentiation of sin x? That is a question. Can we find what we know? We know the differentiation and integration of polynomial equation. But now we are going step by step, right? This is first is why calculus, how calculus. How calculus means how calculus is evolving. So first we started with polynomial equation and we are done. All polynomial equation we can calculate integration and differentiate. But now we are entering into sinusoidal. If what is integration of cos x? I don't know. Let's try some function gx because it looks similar. Some function gx that is sin x. Calculate the differentiation of sin x. So at any point x, if I want differentiation, then I can say sin x plus delta x minus sin x divided by delta x, or sin x plus delta x minus sin minus delta x, this side that side, divided by 2 delta x, where delta x tends to 0. If that is the case, then we have seen that it comes as cos x sin delta x divided by delta x. Sin x plus delta x is nothing but sin x, sin x, sin delta x plus, I'm sorry, sin x cos delta x plus sin delta x cos x minus sin x minus delta x. So minus and in braces sin x cos delta x minus sin delta x cos x. If I do full place mixture, then it will become kind of 2 2 cos x sin delta x divided by 2 delta x. It will come as cos x sin delta x by delta x. Since delta x tends to 0 and sin delta x tends sin delta x where delta x tends to 0, they are same but not 0. So we can divide it. 0 by 0 is undefined, but tends to 0 means they are not 0, near to 0, very near to 0, but they are not 0. If that is the case, if we divide, it becomes 1. So differentiation of sin x is cos x. I am not satisfied personally. Okay, sin delta x, when delta x tends to 0, what is guarantee that it will be same as delta x? If there is a slight difference also, then division would go in thousands. If sin delta x, where delta x tends to 0, the value is 0.001, okay, where delta x is 0.0001, delta x is 0.0001, where sine of 0.0001 is 0.001, then if both are tends to 0, if it becomes like this, suppose, then result would be 10 cos x. Okay, so we cannot just go and say that sine delta x by delta x where delta x tends to 0 is 1. Okay, now question is arising is that can we find the kind of differentiation of sin x? Can we find differentiation of sin x not through first principle? This is called first principle. Sin x plus delta x minus sin x, or sin x plus delta x minus sin x minus delta x divided by 2 delta x. This is called calculating the derivative or rate of change through the rate of collection through first principle. Many times it is not satisfying, like x square. We have given example. If it is x square, x plus delta x minus x plus delta x whole square minus x minus delta x whole square divided by 2 delta x. If I resolve it, it becomes 4x delta x divided by 2 delta x. It becomes 2x. Net solution. Happy. First principle works in polynomial. But sinusoidal, if I want to calculate differentiation of sin x, then it comes as cos x sin delta x by delta x. Sin delta x by delta x becomes 1. This is what generally people imagine, and it becomes cos x. Probably the differentiation of sin x is cos x only, but this is not the very natural way. This is what I believe. Can someone find the differentiation of sin x not through the first principle? You will not get in any of the book. Somewhere you will get, but again it will try to resolve into first principle. Can someone find it? Okay. Now the, like generally what we do, if you are in difficulty in numerical science, take help of algebra. If you are in difficulty in algebra, take help of either vector or calculus or together. If you are in problem with vector and calculus, then take help of different coordinate system. Okay. So then generally I believe so. If no one helps you, polar coordinate system, certainly it will help you. Okay. So if no one helps you, then polar coordinate system would certainly, okay, if no one helps you, then polar coordinate system will certainly help you. What we are trying to get? Consider polar coordinate system. If it is polar coordinate system, then this is a circle. If this is a circle, then this is radius. Can you see? Consider radius is a. Now radius is rotating, fixed at the center. This is x. This is x, and this is y. There is a Cartesian coordinate system inside it. There is a polar coordinate system. If this is a, radius is a, then it is making, okay, if it is rotating, oops, I may leave, it is not that easy to show. Consider two positions of the radius. The horizontal one is the first position of the radius, and then another is next position of the radius. Then it is making theta angle. Can you see this? It is making theta angle. So when radius is rotating from this location, then it is making theta angle with the vertical. Theta angle keep on changing. Can you see? Now theta angle is 2 pi, sorry, pi by 2, 3 pi by 2, and back again to 2 pi or 0. So, and this is radius a. So, a radius is constant, theta is changing. Theta is constant and radius is changing. Now, radius is this much only, but theta is constant. Theta is constant, but radius is changing, growing. So both are independent to each other. So in polar coordinate, there are two independent variables, theta and r, radius, a, radius. So if that is the case, then this is, they are orthogonal to each other. Orthogonal means they are independent. Orthogonal means not only 90 degree, they are independent to each other. Okay, if I say there is radius, if I say this is x-axis and there is radius r, both are independent to each other, not true. If this is the x, if this is radius and this is x, if I decrease the radius, then x is also decreasing. They are not independent to each other. Understood, right? So Cartesian coordinate is nothing but x-axis and y-axis, whereas polar coordinate is radius, and radius is, angle is changing and radius is moving. This is one variation, and radius itself is changing. This is polar coordinate. Now, can someone find the differentiation of sin x with polar coordinate system where I don't go with the first principle? This is our proof. Okay, it may not be available. Started we started a discussion to calculate the differentiation of sin x without using first principle. Sin delta x, sin x plus delta x minus sin x minus delta x divided by 2 delta x, or sin x plus delta x minus sin x divided by delta x. This is first principle calculating the integration. Anyway, I don't know. trigonometric integration. If I know 1, then I can go ahead. Like in polynomial, if I know x to the power 0, then it is x to the power 1, then it is x squared by 2. This looks like if it is whatever n is there, integration is n plus 1, 1 more divided by n plus 1. Then suddenly people say, wow, if I need to find integration of x to the power 3, then it is x to the power 4 by 4. Similarly, anti-integration is differentiation. So, for integration, everything worked very well. Now, people jumped into sinusoidal. What is integration of cos x or sin x? I don't know, because I cannot break it into a polynomial equation. I can break, that is Taylor series, but you need to have derivative. Again, you land up into same problem. What is derivative? So, and if you go with calculation of area, you don't know what is the area under cos or sin x. So, what is differentiation integration of cos x? That is, I don't know. What is differentiation of sin x? Or what is integration of sin x? I don't know. What is differentiation of sin x? Sin x plus delta x minus sin x minus delta x divided by 2 delta x. I am not happy with that approach, because at the end it came as sin delta x by delta x. The hint is, can someone try to calculate the derivative of sin x with polar coordinate system? If it is polar coordinate system, then consider that if this is radius, then along the x-axis it is whatever its impression is, whatever its essence is, that is x. So polar to Cartesian, because x and y are Cartesian and r and theta is polar. What I am trying to get? I am trying to get d sine theta by d theta, because sine x works in polar coordinate. So what is differentiation of sine theta? D sine theta by d theta. This is what I am trying to get. What I am trying to get? If this is theta, then for theta there is a sinusoidal value. Like sine pi by 2 is 1. Sine 0 is 0. For any theta, the value of sine theta. If I make a small increment here, that is d theta, at point theta, when angle is theta, at that moment what is d sine theta by d theta? Means if at point 1 everywhere the differentiation will not be same. So when the angle is theta, d sine theta by d theta, at that moment, if I make unit change in the angle, then how much change will be seen in value of sine theta? At theta, at any theta, that is algebra, at any theta, if I make small change in theta, I call it d theta delta theta. If I make slight change at theta, and theta can be 0 at pi by 2, but everywhere 1 unit change will bring different change. That is algebra. If angle is 0, at 0, if I make 1 unit change of angle theta, then how much sine theta would change? That would be different at when theta is 45 degree, pi by 4. At that moment, if I make 1 unit change in theta, how much unit of change that sine theta will bring? Every theta, that change will be different. It's not constant. That's why differentiation is not division. D sine theta by d theta is not sine theta by theta. It's different. So at every moment that the division is different. So at any moment where angle is theta, at that moment, if I make unit change, then how many unit of change in sine theta value is seen? That is d sine theta by d theta. So that is the concept. So if it is theta, then at that moment consider this is x. At that moment this is x, then this is y. Height is y, that is Cartesian coordinate, and base is x. What is this? Then this is x square plus y square square root. What is sine theta? The relationship between polar coordinate and Cartesian coordinate is sine theta equal to y by square root of x square plus y square. What is cos theta is x by square root of x square plus y square. What we are trying to calculate? D sine theta by d theta equal to d of y by square root of x square plus y square by d theta. Or if I consider y as variable, that is the height as variable, then height as variable, then dy by square root of x square plus y square by dy into dy by d theta. So now we came in polynomial, right? So from angle we came in polynomial, and polynomial we know how we can proceed in. Okay, so that is it. So we will try it. So I can give some time that someone can think on it, that what is the differentiation of sine theta when we know the differentiation in terms of polynomial equation, that is known. Then what would be not by the first principle? That is the easy way, last sort in doing the differentiation. Sine delta x by delta x equal to 1. But let's calculate through the trigonometric way or algebraic way, polynomial way, that we know. So d sine theta by d theta equal to d of y by square root of x square plus y square by dy into dy by d theta through chain rule. Someone can proceed on.